Hi, Rick Tharp with RX Kinetics with another APK program demonstration. This installment we're going to explain the PK model database and the model editor. So let's begin by logging in with our initials. Click Accept Disclaimer. This is our main program screen, and the model editor is under the File menu. Let's click File, Edit Database, and Drug Models. Now, the drug model editor is password protected, and the APK program ships without a password. The first time you access any password protected function, it's going to ask you to enter the password and then confirm it, and from thereafter that will be your password. So you need to pick a password that you can easily remember. This is the model editor screen. You'll notice at the top it has a data bar, very similar to the patient data. You have your browse buttons where you can go forward and backwards through the alphabetized list of drug models. You can skip to the first, skip to the last model. You also have a plus icon for adding a model, a minus for deleting a model. Then you have your save and cancel icons and your fresh icon. Along the bottom there's copy and close. I'll explain copy here in a minute. But let's go over the different fields that are here in your drug model. First field is model name. And the model name has to be unique. The second field is volume and distribution in liters per kilogram. The next field is the correction factor for VD, and this is what's used to determine a dosing weight. This is the percentage over lean body weight that you would add into lean body weight to come up with a dosing weight. So in this example, it's 40% over lean body weight. 40% of the excess weight over lean body weight is added back to make the dosing weight. And this is commonly used for aminoglycosides. For other drugs, if you want to use total body weight at all times, you would make this a 1. If you wanted to use just 20% of that excess weight, change it to 0.2. 0.4 is a number that's commonly used in PK modeling for aminoglycosides. The next field is target peak. The next field is peak predict time, and that's the time after the end of the infusion that you are targeting that peak. For aminoglycosides, it's generally 0. For vancomycin, and since we're using a one-compartment model and it's a drug that equilibrates slowly, has a long distribution half-life, your peak predict time is usually 60 minutes after the end of the infusion. The next field is target trough. The next field is infusion time in minutes. And this is selected from a drop-down, 30, 60, 90, or 120 minutes. The next field is the extended interval dose. This is only used in aminoglycosides for pulse dosing or once daily dosing in milligrams per kilograms. For drugs like vancomycin, it would be zeroed out. The next field is permit serum level analysis. This is a checkbox. You would check it to permit serum level analysis. You would check it. And the reason that's there is because you can use APK to dose drugs other than aminoglycosides and vancomycin. You can use it to dose beta-lactam, to an example, as trianam. You can set up a model, and you can use that to more accurately predict a dosing requirement in a patient with renal impairment. But of course those drugs do not have routine serum level measurements, so you would leave that unchecked. The next field is what the model calculates, either a rate constant or clearance. And this is demonstrated here in vancomycin. We have two different models, the KEL model, which calculates a rate constant, or the CL model, which calculates a clearance. The next two fields relate to how the rate constant is calculated. It's a regression equation. Y equals A plus B times X. So the KEL is equal to your non-renal constant plus your renal constant times creatinine clearance. This is called a Detley plot. It's a regression line that's derived from a population study. And these are normal literature values for aminoglycosides for the renal and the non-renal portion of the KEL calculation. The next fields are pediatric dose and pediatric interval. And in APK, this is defined as patients who are 8 days older and above. The next fields are neonatal dose and neonatal interval. And in APK, these are patients who are 1 to 7 days old. Because neonates, don't clear some drugs as well as peds do. So your dosing interval, for example, here in this model, pediatric interval is 8, but the neonatal interval is 12. So there's an overview of the different fields of a model. And you can add a model by clicking the Add icon. Or another thing you can do is you can create multiple models of the same drug for different patient populations. So let's create some amikacin models. In this case, let's make an amikacin model for OB patients. And it's well known that the obstetric patients have a slightly larger volume of distribution. And that's the parameter we're going to change. And we can save that. And now we can see we have two models, amikacin and amikacin OB. And we can carry that one step further. Let's make an amikacin model for a burn patient. And again, it's also known that these patients also have a higher volume of distribution. So now we have three models, three amikacin models, plain, burn, and OB. Let's close out of there and look in our select drug model drop down, and we'll see that they are available to be used. So that is an overview of the APK model editor.